Welcome to Networks Professionals.
Welcome to this explainer. Today, we're pulling back the curtain on something that's basically an invisible digital shield protecting our everyday lives. We're talking about anomaly detection AI. I mean, if you've ever wondered how our massive modern digital infrastructure keeps humming along despite the literally constant barrage of hackers, fraudsters, and random system glitches, well, you are absolutely in the right place. Let's decode exactly how this technology works.
Think about this scenario for a second. You grab a coffee in New York City, right? And then, maybe 10 minutes later, your exact same credit card is mysteriously swiped to buy a massive flat-screen TV in Lahore, Pakistan. Almost instantly, your bank declines the transaction and pings you with a text. How on earth did they catch that so fast? The industry actually calls this impossible travel because, well, it's physically impossible for you to be in two places halfway across the globe within minutes. But here's the thing. Your bank didn't have a human sitting at a desk randomly monitoring your specific account out of millions. No way. They relied on a specialized system to catch that bizarre behavior the very second it happened.
And that system is Anomaly Detection AI. Basically, it's a tool that scans vast, and I mean unimaginably large datasets to spot outliers or deviations from established norms. You can think of it kind of like a highly advanced digital immune system. Just like your body learns what healthy cells look like so it can aggressively attack foreign invaders, this AI learns your baseline digital behavior. And once it knows what normal looks like for you, anything that deviates from that baseline instantly triggers a massive red flag.
By spotting these deviations incredibly early, the AI stops catastrophic damage before it even has a chance to happen. It is literally constantly on the lookout, flagging activity that indicates three main things: security breaches, operational failures, and illicit activity. And this isn't just about, cleaning up a mess after the fact. This is about intercepting the threat while it's still knocking at the front door. So whether it's a cybercriminal trying to quietly sneak into a server, or even a mechanical part on a factory floor that's vibrating just a millimeter out of rhythm, the AI is watching.
How it works under the hood of the AI. Okay, let's dive into this and see how the gears actually turn.
So we've got two heavyweights here, supervised learning and unsupervised learning. Now, supervised learning relies on heavily labeled historical logs. It trains on massive sets of data like past transactions that we already absolutely know were fraudulent. It learns those exact signatures and looks for identical matches in real time. But what if a hacker uses a brand new trick? Well, that's where unsupervised learning comes in. It requires absolutely no historical labels. Instead, it simply studies what normal everyday behavior looks like and establishes a baseline from scratch. So the really crucial takeaway here is that unsupervised learning can catch entirely brand new, zero-day threats simply because they don't look like your normal routine.
When we talk about that unsupervised learning, the kind that doesn't need past examples to catch a thief, there are a couple of very specific algorithms doing the heavy lifting. The big ones you'll see used in these scenarios are called isolation forests and autoencoders. Behind the scenes, these algorithms are doing all the complex math, isolating those rare, completely out-of-place events that are hidden deep inside absolute oceans of perfectly normal data.
But here's where it gets wild. The AI isn't just looking at how much money you're spending. It evaluates incredibly granular real-time context. It looks at the device ID you're logging in from, it looks at your IP address, and yes, it even evaluates your typing speed. That's right, the AI is secretly judging how fast you type. If you normally kind of peck at the keys when entering your password, but suddenly your account is being accessed by a script typing 1,000 words a minute, well, the AI knows it's not really you, even if the password is 100% correct.
The battlegrounds, industry applications. Let's shift gears and look at where this digital shield is actually deployed out in the real world. In banking and finance, the anomaly is that impossible travel, or a swipe in a new country that we talked about earlier. The disaster averted? A completely maxed out stolen credit card. Over in cybersecurity, the AI isn't really looking at credit cards, it's monitoring network traffic. If it sees a sudden, massive bulk transfer of files or some truly bad network traffic, it slams the door shut. This is exactly how companies stop impending ransomware attacks before the hackers even have the chance to encrypt and lock down the company's entire database. It is the ultimate frontline defense.
Now, what's really interesting about this slide is the sheer diversity of applications. Look at manufacturing. We aren't talking about hackers here. We're talking about heavy machinery. The AI monitors sensor data on an assembly line. If a machine's temperature or vibration goes slightly irregular, the AI flags it. It's literally predicting its own mechanical failure before the physical breakdown even occurs. It's like the machine knows it's sick. In healthcare, it's scanning for abnormal billing patterns or medical readings to stop insurance fraud. And in e-commerce, it's hunting down suspicious chargeback sprees and fake reviews to flag fraudulent vendor activity. It is just wildly versatile.
Building your own AI shield. Now, you don't have to be a multi-billion-dollar bank to implement this system yourself. Let's talk about how you can leverage this. If you really want to get into the weeds of the academic and technical methodologies, the source material points us towards some fantastic deep dive resources. To quote directly, to explore how leading frameworks and academic studies approach these algorithms, check out the IBM Fraud Detection Guide or review the technical methodologies outlined in the ResearchGate Anomaly Detection study. If you're building a system, those are absolute must-reads for understanding the precise mathematics and theories behind these complex algorithms.
But before you write a single line of code or buy a piece of software, you have to follow these two foundational steps. First, pinpoint exactly what data you're monitoring. Are you looking at financial transactions, server log files, or maybe IoT sensor data from a piece of hardware? Second, assess your baseline. Basically, do you have months of cleanly labeled historical data to feed a supervised learning model, or are you starting entirely from scratch and need an unsupervised learning algorithm to figure out the baseline for you?
Identifying those two factors will instantly dictate the best algorithms and frameworks for your specific project. So I'll leave you with this to think about. Look around your own digital environment. What crucial data are you currently leaving unmonitored, and are you ready to finally build your own invisible digital shield? Thank you so much for joining me for this explainer, and keep learning.
Thanks for watching.